Let's start off graphing this rational function the same as we would with anything else. We're going to look at the x-intercepts first. You don't have to do it in this order, but I think it's helpful. So x-intercepts come from factors on the top, and if you look at these things, you can see that this one is -3, 0. This one over here is 1, 0, right? We're setting each of those factors equal to 0 and solving it. So those are our x-intercepts, -3, 0, and 1, 0. Okay, y-intercepts are found not from the factors in the function, but these are from, well, if you take a look at what happens to the function when you set x equal to 0. Okay, we set x equal to 0. That basically says, where does the function exist at x equals 0? In other words, on the y-axis, right on that line I drew. So we set x equal to 0. This is the best part. You just cross out all the x's, right? 0, 0, 0. Those are all zeros now. What's left? It's -9/2. So we say x equals 0, y equals -9/2, like that. That's the y-intercept. Vertical asymptotes are interesting. These come from factors that are on the bottom of the fraction which do not appear in the top. And you'll notice there's no x plus 1 on the top, so this is a vertical asymptote right there. And that's going to be located at x equals -1, because what I'm really doing, remember, I'm taking this factor, x plus 1, and I'm setting it equal to 0 and solving for x. Okay, so that gives me my vertical asymptote. And now end behavior, we'll get to that one last. The question with end behavior is always, is the function top-heavy, bottom-heavy, equal weight? What do we have here? So take a look at those front functions right here. See those x squareds? They're equal exponents. We call that equal weight. And when you have an equal weight function, what that means is you have a horizontal asymptote, and it's located, so this is the end behavior asymptote, right, the horizontal asymptote, and it's located according to the ratio of the coefficients. Now, some people would look at this and they would say, well, wait a minute, you got a 3x squared on top, and it seems heavier than the 2x squared, right? Well, that's the wrong way to think. When I say equal weight, heavy weight, and so on, all I'm really looking at is the exponents, so keep that in mind. These coefficients are useful, but they're only as a tiebreaker in case of equal exponents. So I would say y equals, and we take the ratio of those coefficients, 3/2. So that's my horizontal asymptote. And with this is all the key features of my graph, so I think I'm ready to graph this thing. Let me just, looks like I lost my y-axis at some point. Let's put that back on here. Okay, so now I'm going to draw asymptotes in red, just all the asymptotes, and it looks like I've got a vertical asymptote at -1, something like that, and a horizontal asymptote at y equals 3/2, so I don't know, like that. Okay, so there's my y equals 3/2 right there, and this is x equals -1. So those are my asymptotes. And now let's draw some intercepts. I want a little bigger dot. Make this a little more bold. X-intercepts are at -3, 0, I don't know, somewhere over there, and 1, 0, somewhere over here. And now my y-intercept, remember that 0, -9/2, so that's like down here somewhere. Okay, so we've got some nice intercepts on there, and all that's left to do is to graph the function. Now, this seems obvious. My function has to connect those two dots right there. And as you're looking at the vertical asymptote, I think this one is pretty clear. It's going to keep on going down. It's going to hug the asymptote right there. And this side over here is just going to come up, and it's going to hug the horizontal asymptote like that. But on the other side, we've got an x-intercept that, well, it's a little interesting. You might be used to vertical asymptotes always having this behavior where it goes up one side, down the other, right? And that's often how they go. But that's only when they're odd behavior. This one, if you look closely, see that 2 right there? That's even. That's an even exponent, which means we have an even asymptote right here. And what that means is you have something that's symmetric. Okay, it's going down and down. Notice how both of these are going down. That's even asymptotic behavior. And it's from the exponent of 2 on the denominator. So here's our function. Pretty easy one to solve, I think. And that's that.